Okay, we're in section 12, and this is the continuation of polynomial factoring. And these are going to be what's called special cases. Although I don't like the term special cases, I really all see all factoring as basically being trial and error until it becomes so difficult where trial and error doesn't work, and there's other algorithms to go through. But right now, what do? We did GCF. That was last section. We did groupings, and we did quadratic. Now they say there's special cases over here. And so I'm going to claim over here, special, even the word special doesn't sound good to me, but I only had two boxes on these special cases. And I'm going to tell you what those two boxes that you probably should know, but I would claim also these can be done by trial and error, but most students can't do them by trial and error. They need a formula for it. And that's unfortunate, but a formula is not bad. A formula allows you to write an answer down very quickly. So we've covered this, and these are the two ones that you would need to know to do this problem set. But here's the problem. A lot of teachers, when they teach us stuff, they say, oh, there's many special cases, right? There's 5 special cases, they say at this level. So they would say the difference of perfect squares, a squared minus b squared, perfect squares type 1, perfect squares type 2. Oh, here's my 2 favorite, which is the difference of perfect cubes and the sum of perfect cubes. I'm going to claim for the most part in the problem set, I'm not looking at these. I will mention them to you, but the bottom line is trial and error works beautifully on these guys over here. And most students can do that without knowing the names of these guys over here, but they can't do 4 and 5. So what do they need to do with 4 and 5? If you see the difference of perfect cubes or the sum of perfect cubes, you are going to have to use these formulas. These formulas look remarkably the same to me. There's a difference. So now we're going to go to the examples. Let me go to that. And I'll go through those examples. But again, you're going to see me doing the same thing over and over again, which is factoring these problems over here. So let me just go to the examples. Give me a second. I made a mistake already. Okay, as I go through the problem set, we'll talk through it. Now, granted, if this was another teach course, they'd say, oh, this is a special pattern. You would need to know a formula for a special pattern. I'm not going to say any of that, but I will talk about the special patterns over here. And let me just briefly talk about that, and I'll do the first one over here. I'm going to say, looking at the problem, they said factor in. Certainly, there's no GCF. There's not 4 terms, so I would never try that. But I do notice there's a quadratic, and I would say I could definitely try this one by trial and error. All right. Now, I noticed when they put the letter S down over here, that looks like the number 5 to some students. So I'm not going to use that symbol. What I'm going to use instead is I'm going to use what's known as a cursive S. I'm going to read the problem right from the get-go by using a cursive S. So S squared minus 81. And I'm going to use what's called trial and error to do this. But I will talk about other students. Other teachers would call, oh, this is special, learn the pattern. But anyway, how do you get S squared? I'm looking at the first term, which is S and S. That would give me S squared. And 81, there's only 2 choices for 81. It could be 81 and 1. Actually, I shouldn't say it's more than 2 choices. 81 and 1, maybe 3 and 27, or 9 and 9. I'm going to try 9 and 9 because they're the smallest numbers I can come up with. You certainly with the first term, you get S squared, you get the last term. Let's try some signs. And I'm going to see if this works. S squared plus 9S minus 9S minus 81. What do you get over here? S squared, 2 middle terms disappear, minus 81. Did it work? It sure did. This is the only possible outcome on it. Someone says, well, what if I wrote down S plus 9 times S minus 9? It's the same answer. There's no different. Let's look at the key. And do I see that? Yep, I see it. Okay. So someone said, oh, what's a special pattern over here? This is what's known as the difference of perfect squares. So if I were to write that down, the perfect squares would be S squared minus 9 squared. And the pattern for different squares, I'll write it down for you. No, you don't have to memorize it. A squared minus B squared, that's a difference of perfect squares, factors very nicely, A minus B to A plus B. Difference of perfect squares. All right, let's do the next one. Next one's a little more complicated. And noticing this over here, again, I'm looking at it, And my claim over here, just looking at it, there's no GCF. I don't have four terms. And I don't see an apparent quadratic. So what I'm going to claim over here is maybe this is one of those special pattern problems. And I only have two special patterns to memorize. All right. And I'm going to say what those special patterns are. I'm going to write this on the side for you. So I'm going to say the special patterns to remember is a cubed plus b cubed. You need to know this one. And you need to know a cubed minus b cubed. These are the only two that I'm asking you to memorize because most students can't do it by trial and error. Well, let's write this down. This is going to be a plus b. This one's going to be a minus b. And that's going to be multiplied by a quadratic. A squared minus ab plus b squared. And again, in class, we multiplied that out and we verified that this is true. This is going to be a squared plus ab plus b squared. All right. I'm going to tell you this now. This quadratic over here, not factorable with the numbers that we discussed in class. And this is not factorable. So what does that mean? If we can get this thing into that form, we're going to do really well with the problem. Let's put this down. What is going to be 27y cubed minus 8? Let's write this down. Again, what I'm pointing out, I'm just doing the problem over here. What I'm going to do initially is just write down what the cubes are. All right. So what's the first one going to be? 3y. This would be 2. Let me point out what it is. 3y cubed would be 27y cubed, and 2 cubed is 8. So what I'm going to claim over here, I'm using, and someone says, which one are you going to use? And I want to make sure you know which one I'm going to use. So I'll put this down for you. I'm using this one over here. So I'm going to write this over here. What's the A then? Whoops, sorry about that. The A, I did it again. The A is 3y. And what's the B? The B is 2. So what I want to do is I want to see if I can do it. So it's going to be A minus B, 3y minus 2. Then what do I do? It says a squared. Well, what's a squared? 9y squared. Then what do I put down? Plus a times b, that's 6y. Then what do I do? Plus b squared. What's b squared is 4. We're done. Now, by the way, when I say we're done, it may be wrong, but at least we're done. I'm going to check it. Now, someone says, I would never check this. That's up to you. I want to check it. And what do you get? 27y cubed. I'm using the distributive property multiplication plus 18y squared plus 12y. Then what do you get? Minus 18y squared minus 12y minus 8. When the line goes down, add it together. Combining like terms, by the way. Is that what I wanted? Exactly. So that's the correct answer. I want to go back to the key, though, and see if that's the answer they've listed. Because who knows, maybe I could totally deceive myself. So what do you see? 3y minus 2, 9y squared plus 6y plus 4. Worked out beautifully. Let's go to the next question. And I'm looking at it. And someone says, why do you look at the problems? Well, I want to see if I can understand it. And looking at it, what I noticed right from the get-go is that this thing over here has no GCF. It also has two terms, so I can't do this grouping thing. But I'm starting to see there may be related to a quadratic. And why is that? 4 has something to do with number 2. So I'm going to trial and error on it. So I'm going to say y squared times y squared is y4. How about the 16x4? I would say 4x squared and 4x squared. I'm not saying it's going to work. I'm just saying I'm willing to try it. I'm going to put some signs down here and I'll give it a shot. I'll put down minus and plus. If I were to multiply that, what do you get? Y4 plus 4x squared y squared. This was on us trying. Minus 4x squared y squared minus 16x4. Well, what's nice about this is 2 middle terms disappear and I get exactly what I want. I gotta be honest with you. A lot of students, they say, oh, gee, I'm done. Let me put a box in that. I'm not done. I'm going to erase this. I'm not done. I'm going to erase it. Someone says, why are you not done? I'm seeing quadratics and I want to try it. So I'm looking at this first factor, which is y squared minus 4x, and I'll put this down for you. Maybe y minus 2x and y plus 2x. Again, I want to point out I'm looking at. I'm just looking at the first factor. That's all I'm going to look at. I'll look at the second factor later. I'm getting a little better at multiplications, and I hope you are too by trying. I would certainly get y squared, and I would certainly get minus 4x squared. And the two middle terms would disappear. Now, what I want to claim over here, you should also try this one. And I want to write that on the side for you. So y squared plus 4x squared. No matter what you do with this, and by the way, I'm going to claim it is factorable, but not at this level. But you could try y and 2x and 2x. You don't have much choice in this, something like this over here. But this would never work out using these numbers. You're not going to get it. You can try 1 time, 2 times, 3 times. You could try 1,000 times and you're not going to get it. It's not going to work. So I'll just write that down then. If it's not going to work and I tried all that time, I always put this over here. And I'm going to say I'm done. Let's write this down for you. Y minus 2x. I'll put a box on in a second. Y plus 2x and y squared plus 4x squared. All right. We'll talk about the original pattern of the problem now. Let's look at it. Y minus 2x, y plus 2x. I'm looking in the answer key, by the way, and y squared plus 4x squared. All right. So let's talk about the original pattern. The original pattern is actually the difference of perfect squares. And let me write that down for you. Again, I'm not enforcing it, but other teachers say, oh, you have to identify the pattern, name the pattern, put the pattern down, and follow the pattern. What's the pattern? It's a perfect square pattern. A squared minus b squared, which would factor to be a minus b, a plus b. It's a difference of perfect squares. Let's go to the next one. Next one I'm looking at, and I'm wondering, they want me to factor it, and I'm looking at it, and there's no GCF. There's only 2 terms, so not a grouping pattern, and it's really no apparent quadratic. So I'm going to say it probably has something to do with that, perfect cube problems. Let me write down what I think it's related to. A cubed minus b cubed. And yes, you need to memorize this if you can't do it by trial and error. Let's write it down. This will be 1 cubed minus, well, let's see, what cube would give you that? Would be 4, right? 4x cubed. So now I know my a is 1, and I know my b is 4x. Well, let's write it down. What are you going to get? A minus b, 1 minus 4x. Then you can get a squared. I want to point out we're looking at the pattern. So let's see, what's a squared is 1 plus a times b. Well, 1 times 4x is 4x plus b squared. And what's b squared? Well, 4x squared would be 4 times 4, which is 16. And x times x is x squared. Yes, I know that's quadratic, but it's not worth trying at this level. So I want to look at the answer key and see if I got it right. Bingo, not bad. Let's go to the next page. And again, I realize for some students, this goes very quickly. They're slow to process information, and that happens. You slow to process information, try again. What else can I tell you? Keep trying. Not everyone works at the same speed, by the way. So we'll take a look at it, and it looks difficult, but I have to look at it. And the first thing I notice about this guy over here, there is a GCF. What's a GCF? It looks like y squared. So I would factor that out. And what would you be left off with? X squared minus 7x minus 8. All right, so what did I do? I looked at the problem. I factored out the the y squared. Let's see if it works. You get x squared, y squared, minus 7xy squared, minus 8y squared. Worked beautifully. This could be the answer. Maybe there's nothing else to do. What I want to claim is I still look for trial and error. And no, this is not a special pattern. X and X would give me X squared, right? 8. Well, how can I do that? Could be 2 and 4. Could be 1 and 8. Well, I'm starting to think it's probably 1 and 8 because I see the 7 and they differ by 1. I'll try that down. Let's see. Let's try this. Minus 8 plus 1. You know what I say? Let's try. I don't know if it works. Let's see. You get X squared. That's certainly for sure. Minus 8 plus 1 is minus 7x. That worked beautifully. You get minus 8. Again, if you want, you can write this down this way. We'll look at the key later. It's not considered to be a different answer. Factorizations are unique. Look at your key. Everything works out fine. Let's go to number 6, our last problem. And I'm looking at it. And I'm wondering, what's my first step? GCF. B squared comes out. And what does that give you? X squared plus 6x plus 9. Now, this happens to be a special pattern, but I'll be honest with you, I don't care if it's a special pattern. I can still do trial and error on it. So let's put this down. What do you get? B squared. X and X, my only choice. How about for 9, 3 and 3? Looks like plus plus. Let's check it out. You do get X squared. 3x and 3x is 6x, and 3 times 3 is 9. These are perfect squares, by the way. So what do you really get over here? B squared, X plus 3 squared. That's also a fine looking answer. It's the same answer, by the way. Let's look at the K. I'm seeing the B squared, X plus 3, X plus 3. And again, this is the same exact answer, just 2 factors. They're perfect squares, all right? And that's also in this section of the notes where a lot of teachers would demand what that perfect square is, all right? And that's a perfect square problem, all right? What's the perfect square we're talking about? I'll write this down. It's A plus B squared, which turns out to be A squared plus 2AB plus B squared. I don't think that's necessary, though. These are really simple trial and error problems, and you should know that just by looking at how simple that problem was, all right? Here's the deal, though, and I can't say this enough times to you. You need to reinforce, and this is where a lot of students, they're very weak on this thing. And I'll be honest with you, if you're weak on your education, your opportunities later in life will just be, they'll be horribly curtailed, all right? So what I'm gonna claim over here, looking at it, is, homework, all right? Let me just point out what I mean by that. You've got to work. What are you working towards? You're working towards a goal. What's that goal? To be able to do the problems that we're presenting to you, and the hope that when you get to the exam, you'll do really well in our exams. Our exams are just repetitions of what we've covered in class, what you've practiced in the homework, and what you're studying for in those exams, all right? So do the homework, all right? Really important. Not doing homework, you're really going to find yourself at a severe disadvantage, not only in the class, but in the future, in you're applying for jobs, things like that. You'll find yourself at a severe disadvantage. All right, thank you for paying attention, and I'll see you guys next time.